this is another ambiguous case. I've skipped example 4, we're coming back to it. This is example 5, let's check this one off real quick. It tells us that B is equal to 70.5 degrees. A is 83.5 inches, and that B is 61.4 inches. Okay, so first you draw yourself a triangle, say what do they give me, draw myself a triangle, and I say this is A, this is B, this is C. They gave me this angle, they gave me this side, they gave me this side. This is A, this is B, this is C, and so they gave me side angle. I realize this is the ambiguous case, so this is how I proceed. I find the only angle I can with the given information. So let me make this bigger just so I can draw stuff in it. A, B, C, 70.5 degrees. Little a is 83.5 inches. Little b is 61.4 inches. So they say, hey, here's the information, go find out the rest of the triangle. So start by finding the only angle you can. So the only other angle I can find, I know the B and the B, the only angle I can find using law of sines is angle A. So we'll begin there. So I'll say the sine of angle A is to the side A, 83.5 inches, as the sine of angle B, which is 70.5 degrees, is to the side across from it, 61.4 inches. And we'll cross multiply, and we'll find that the sine of A is equal to, let's see, 83.5 inches times the sine of 70.5 degrees divided by 61.4 inches. And all I did right there was I cross multiplied, and I got that 61.4 times this is equal to this times this. And then to get sine of A by itself, I divided both sides by 61.4. So how I find the angle A, again, is I'll take the inverse sine. So take the sine inverse, the sine inverse. So in my calculator, I will say, I'll press second sine, which is the sine inverse, and I'll say 83.5 times the sine of 70.5, and that's my numerator, divided by 61.4, and I'll hit enter, and it gives me error, basically, error. So if I go back, I'm like, hey, did I type that in right? So let's see here. What is this value? Before I take the sine inverse, 83.5 times the sine of 70.5 divided by 61.4 gives me 1.28. If I try to take the inverse sine of a value bigger than 1, greater than 1, or less than -1, that is outside the range of a sine function, I will get error every time. So I got error. That's why I got error. When I get error, this is telling me there is not even one triangle that can be formed out of this. In this case, 0 triangles exist. All right, so far with the ambiguous case, we looked at an example in the last video where it was ambiguous case and one triangle exists. We tested for a second one. There wasn't enough degrees to make a second one. This is an example that you come across where 0 triangles exist. Sometimes that could happen. Now let's look at the third. We're going to go to example 4 now. So example 4 is this on your worksheet. What do they give us here? Right here, example 4 says this. It says that angle A is 69 degrees. Okay. Angle A is 69 degrees, and that little a is 86 feet, and that little b is 91 feet. So draw yourself a triangle, A, B, C. Say this is 69 degrees, at little a is 86 feet. Little b is 91 feet. That's little b. They gave me side, side, angle. Side, side, angle. I'm looking at the ambiguous case. Okay, let's go. First, you find the only angle you can with the given information. They gave me everything I need to know about A. I'm going to try to find angle B using law of sines. So I say the sine of B is to 91 feet, as the sine of 69 degrees is to 86 feet. I will cross multiply and take the inverse side. So sine B will end up equaling to 91 feet times the sine of 69 degrees divided by 86 feet. Let me make sure I did that right. This times this is equal to this times this. If I want to solve for sine B, I'll divide both sides by that. Good. So now I'm going to take the sine inverse of both sides and see what happens. Sine inverse, sine inverse. What's going to happen here is sine inverse and sine will undo each other. I get angle B. Over here, I'm going to find out what angle B is equal to. So I take sine inverse, second sine inverse of 91 times the sine of 69 divided by 86, close parentheses, and that's my sine inverse, and I hit enter, and I get 81.06 or 81.1 degrees. 81.1 degrees. I realize I'm doing ambiguous case, so I'm going to label that B1. 81.1 degrees. Okay. The fact that I did not get error means that at least one triangle is going to exist, and I can finish solving this, and I will finish solving this, but before I do that, let's go over here and check. Is there a second triangle? Okay, let's see. Redraw the triangle with the given information. That does not change. A was 69 degrees. Little a was 86 feet. Little b is 91 feet. And then this would be B2, right? B2 is what we're looking for here. So B2, how do we find B2? Well, B2 is equal to 180 degrees minus B1. If it's going to exist, the second triangle would be formed possibly by this with the supplement of angle B. So let's see what that would give us. 180 minus B1. Oops. 180 minus B1 was 81. Would be 98.9. Okay, 98.9. 98.9 degrees. So if this is going to exist, B2 would equal to that. So here's the deal. Is there enough angle left to form a third angle C? So how we do that is the test. We say 180 degrees minus 69 minus what we think B2 is, 98.9. And if we get something bigger than 0, we know we can make a second triangle, I mean. So we'll take, let's see what that is. 180 minus 69 minus 98.9 gives me 12.1. That is bigger than 0. That means this is angle C, and that this is B2. So a second triangle exists. Okay, so let me label that. Then C is going to be 12.1. B2 is 98.9. And if I want to say this is C2, because this is the second one, then I'm going to find this little C2. All right. Now, the rest is stuff you've done before. That was the big deal. Is there two triangles? Once we know, the rest is figure out what we got, what we don't know. So here's the things we had to figure out here. We needed to find B1, which we did. It's 81.1. We need to find, we know little b, we know little a. Oh, we need to find out what C is. What is C1? We'll take 180 degrees and subtract 69 and 81.1 to find that. So let's see. 180 minus 69 minus 81.1 is 29.9. That's what this one would be. 29.9 degrees. So we know little a, we know little b. The only thing left to do is find little c, and if you want to label it C1, that's fine. How can we do that? Law of sines. So let's pick information we know. I'm going to start with the given information. That's usually safest. It's most accurate to use given information as much as possible. So let's say here, a, little a, is to the sine of a. Let me start with what I don't know. I'm going to start with little c. C1 is to the sine of C1, is to the sine of 29.9 degrees, as little a, 86 feet, is to sine of a, is to the sine of 69 degrees. And I will cross multiply and solve for C1. So I'll say C1 is equal to 86 times the sine of 29.9 divided by the sine of 69 degrees. And let's see what we get. 86 times the sine of 29.9 divided by the sine of 69 gives me 45.9, and the units are feet. 45.9 feet. First triangle done. Let's go over here to the second triangle. What is left to find? Okay, we needed to discover what B2 was. We figured that out. B2 was 98.9 degrees. We needed to know what C2 was. We figured that out as 12.1 degrees. The only thing left is to find little c2. Let's do the same thing that we did over here. Use law of sines. C2 is to the sine of C2, which is 12.1 degrees, as little a, which is 86, is to the sine of 69 degrees. 86 feet is to the sine of 69 degrees. And we'll cross multiply and solve for C2. So with my calculator, I'm going to say the sine of 12.1 times 86 divided by the sine of 69 degrees gives me 19.3. C2 is equal to 19.3 feet. 19.3 feet. So those are the things that can happen in the ambiguous case. 0 triangles exist. 2 triangles exist. And in the last video, 1 triangle exists. But you're obligated to check to see if there's more than one triangle.